All right, this is the last of our little fun trig problems for today. This one's a little bit different because they've given us tangent. Now, tangent makes things a little bit difficult because now we're going to have to deal with tangent and how to get sine and cosine from that. Okay, so I'm going to show you how to do this using the identity equation, and then we'll deal with it from that point. All right, so the first thing that we need to do is to recognize that tangent of theta, as shown in the last video, is sine of theta over cosine of theta. Okay, so sine over cosine is therefore equal to -2. Now I can solve for sine of theta just by multiplying both sides by cosine, right? Multiply by cosine, and so those cancel out, leaving me with sine of theta equals -2 cosine of theta. All right, now from this point I have a sine and a cosine. I can solve that fairly easily by doing something like this. Remember, you had sine squared of theta plus cosine squared of theta equals 1. So you can actually solve for one of these pieces, either sine or cosine, just by going through that process. So we're going to go ahead and say, all right, well, in that case, I'm going to solve for cosine, just for the fun of it. So we'll go cosine squared of theta equals 1 minus sine squared of theta, which then, of course, we will take the square root of both sides. So cosine of theta equals plus or minus square root of 1 minus sine squared of theta. So there we go. You now have something solved for cosine. We can now take this and plug it in, which means that we now have sine of theta equals -2 times the square root of 1 minus sine squared of theta. Now, how did that help me? I now have a quadratic sine function and I got a square root. Okay, hold on. Just wait a second. We're going to get there. Now, obviously the square root is an issue. Thinking like a mathematician, we say, how is this like what we've done before? It isn't. Okay, yes, but it does have a trig function. It's got a number. Okay, how is this different? Well, obviously it's got the square root there. Okay, so thinking like a mathematician, how do we get rid of a square root? We do the opposite, right? We square. So we're going to square both sides. Root squared, root squared. And so this is going to become sine squared of theta equals, now I've got to square the -2, which will be 4, and then I got to square the square root, which is why I didn't really need the plus or minus here, because I'm going to square it anyway. So a negative squared is positive, a positive squared is also. So that would be 4, and then obviously the square root will go away, leaving me with 1 minus sine squared of theta. And so from this point, I can distribute the 4. So I'll have sine squared of theta equals 4 minus 4 sine squared of theta. Then, of course, I'm going to add the 4 sine squared of theta to get all the sine squares of theta on the same side. And if I take 1 sine squared of theta and add 4, I now have 5 sine squared of theta, which is equal to 4. I can now divide by the 5. I'm trying to get theta by itself, right? This is the same. You may say, but I've never done this with trig. It doesn't matter if you've done it with trig. Mathematics does not change. Algebra is consistent. We're trying to get theta by itself. When you try to get theta by itself, the first thing you got to do is make sure that there's only one theta there. You can't get it by itself if there's 2 of them. So we move the thetas over to the same side. You could have subtracted the sine squared theta. It doesn't matter. But you got to get all the thetas together. Okay, all the thetas are together now. So how do we get it by itself? We start doing the opposite. We start peeling pieces away. Okay, well, the 5 times is on the outside. That's the weakest link, so we'll do that first. We'll divide by the 5, which now means that I have sine squared of theta is equal to 4 over 5. Okay, keep peeling away the layers. The next thing we got is that it's a squared. And so we're going to take the square root of both sides, which of course is going to leave me with sine of theta equals plus or minus, I've got the square root of 4, which is 2, and I can't square root the 5, so it's got to stay in the root. So there you go. Again, if this makes you nervous, you can rationalize it. If you rationalize it, you should get 2 square root of 5 over 5, still plus or minus. Okay, so there's sine, and now we need cosine, right? So we need cosine. Now, I haven't paid attention to the restrictions yet. We'll get to that in just a minute. Now, obviously, cosine you can get in a number of different ways. This doesn't want to go away. So I'll leave it up to you to figure out how you want to do it. I'm going to go ahead, and I like doing my little triangle thing. So as long as I'm doing this, this will help me figure out whether I want the positive or negative sign, or if I want both of them. So I need to go from 3 pi over 2 to 2 pi. So I go 0, pi over 2, pi, 3 pi over 2. If you don't know these four yet, you need to memorize these by next class, because these are going to be very, very important. It's just like knowing 90, 180, 270, 360. You got to know that when you're dealing with geometry problems. And so dealing with radians, you've got to know these four. All right, so we got those four down. We're looking for anything between 3 pi over 2 and 2 pi, which of course is at the same place as 0. And so we therefore need this. Let's see, if I have a positive sign, that's going to be going up here somewhere, either there or there, I don't know yet. A negative would put me down here or here. Therefore, I want the negative sign, right? In order for it to be in this quadrant, sign's going to have to be negative. So let's go ahead. We'll get rid of the positives, so it's just negative 2 over root 5. So now I can go ahead and start putting my triangle together. Yes, the triangle does have to be here because it's always relative to the x-axis. So sine is negative 2 root 5, and so from there we should be able to work out what our other side here is. If you do Pythagorean theorem here, you will find out that it is 1. Don't believe me? Well, 1 squared is 1 plus 2 squared, which is 4. 1 plus 4 is 5. Take the square root is square root of 5. If that was too fast for you, then you write out x squared plus negative 2 squared equals root of 5 squared and work it out. You can do Pythagorean theorem. So from this point, we now have all the sides, and so we know that cosine of theta equals the adjacent, which was 1, over the hypotenuse, which is root 5. Note that the cosine is positive here because we're moving to the right, and so therefore I don't need the negative possibility. All right, you'll notice that the tangent is negative 2, the opposite over the adjacent. You'll also notice that the slope is negative, which corresponds with the fact that we have a negative tangent. Okay, don't get confused with a value for tangent and a value for a hypotenuse. All right, so with that, I'm done with this video. Hopefully that was helpful to get you through the sine and the cosine. Obviously, the methods that we learned in the previous videos to get the sine and cosine will still apply. I used the triangle and Pythagorean theorem to get from sine to cosine. You could have just as easily used the identity here. Okay, so that's all I got. Oh, sorry, no, that's not all I got. One other thing, if you wanted to reason through the tangent, you could have just kind of drawn your triangle and said, okay, tangent is negative 2. So that could either be negative 2 over 1, or it could be 2 over negative 1. So remember, tan is sine over cosine. So if the sine had been negative 2, that would be, remember, sine is y, cosine is x. So sine is y, so negative 2 would have been down and then to the right. So that would have been this triangle right here, would have been negative 2 and 1. Or it could have been 2 positive and 1 negative. So positive 2 or negative 1. That would be my negative 1. That would be my positive 2. Both of those, you know, have a negative tangent. From there, you could have done Pythagorean theorem to get this side. Therefore, with the Pythagorean theorem, you could have finished it up and gotten the sine and cosine. So just a little added tidbit. You can reason through it. You don't necessarily have to do the identity. All right, good luck on your homework.